Hello there, welcome back. Welcome back to the session 3 on episode 4 on the generative AI GAN model creation. So if you look at the playlist, this is what we have done up to now. We have just initiated our GAN model creation on the episode 4 session 2. Let's start developing the GAN model. Only 2 sessions are done, so let's continue from there. If you look at the previous session, on session 1, we just introduced very basic 2 lines of coding with related to our GAN model creation. As you may remember, we just import the main torch library, and we just understood what is torch NN, and that is a neural network, a submodule on main torch library. So let's continue to understand a little bit of functionalities and especially the functions which we have to use in upcoming our GAN model development process, which is the ongoing process at the moment. So the session 3, today we are going to focus on one function called torch.random. Now we know what is torch is a main library in PyTorch, and random is just a function. Let's try to understand what it's trying to do here. You can see in the document, I'll upload this one. It is almost explained. It is using PRNG, pseudo-random number generator. It's a mathematical algorithm. So that's the algorithm behind this particular random function in torch library. So if you look at the example here, you can see import torch. We know this one now from torch, import likewise. And this is just to import the sum torch random. So what will happen, a tensor with 5 random numerical values will be generated if you use this one. Now this import the sum function from torch module. So this is just to, because we are going to sum up the values. First thing is calling the torch library, then we are calling from that the sum function, and after that we are again calling the random function to generate random numbers. So this will create a tensor with 5 random values, and we are going to sum up those values. We are going to print it. Very simple, very simple. And then last day we explained what is a tensor is, and we just mentioned it's a kind of a multi-dimensional array. But actually we need to get out from that definition, because we mentioned the same thing. Tensors are not arrays. So we can now say it's a way of representing mathematical data. So it is obvious now, because the random function is going to create some numbers, random numbers. And if you really do this in practically, you can try this code. Very simple. If you go to Python, let's do a small practical here. You can see, just take this one. We can import torch. Import right, and we have it. Import torch, and just call in the. Then let's call this sum function. Let's copy that code here, and you can see that one. Then x torch random. We can either put this one right away, this, and see what happens. That is just assigning to a variable and printing it, calling back. Yeah, let's do this first. Okay, so now you can see it does output just to say it's a tensor type what is created. Tensor data type, that's what it says. Tensor acronym is automatically given here. That is, it says is what is the output of this random function is tensor type. That's what data type. And you can see now the values, because I asked him to create 5 values. Now it shows me the values 0, 0. Because by default this PRNG, the PRNG algorithm creates values between 0 and 1. That's why we see all less than 1 values and higher than 0 values. So that's how it goes. That's how this random function works. And further we can continue this one as well, just to see the totaling of this value. Let's see the sum, how the sum function also works. Very simply we can assign the same set of Now this one will generate another random because I call the function again, another set of random values. But again, it's going to be same series like above, less than 1. And now we can just sum that one and assign it to a variable. Or we can right away print it, but some of this for methodical way of doing that. And we can call that variable here, and we'll see the output. Now that's what this is, tensor data type, and this is the total of these values. It is simple, total of these values. That's what. That is very basically what this random function does. I think all explanation is given here. In general, it is considerable. That's okay. You can read it and see. I'll upload the document, and each and every code line is also explained here. And we have few more extra things also other than the things that I just demonstrated. So this is the explanation for what I just explained, or the coding as well. And y some x, that's okay. Print y, that's fine. Yeah, assume the value x. Yeah, that is the way it's displaying how the calculation is being done. Okay, so this is something called seed. There is something extra. I mean, we might need these things in upcoming our AI model creation coding. So that's why we are just trying to get familiar with these things. Now seed is something like that. Now in this case, the starting point, it just defines random values between 0 to 1. What if I want to hold the same set of values again? I need to sum the same value now, because if I again repeat this one, let's say I'm going to use this torch random again. Let's try that. Then now you can see it gives me another set of values. See, it's different to the previous set of values. So that's why again, I mean, number of times I'm going to call is going to generate new set of values. Next again, another set of values. So what if I going to recall this same set of values? I need to get the sum of the same values which I have previously already used. So then this seed is very important. Seed is nothing much. I can just define a place where the values are getting started, and I can save it and I can recall it back. That is what the seed is. And if you want to define, you can say use torch, and there's a manual underscore seed and the value like that. So let's try to understand this one later. But this is just to tell you there is a mechanism to recall. Even though it is random, we have a mechanism to recall and calculate the same set of value which is random function as previously generated. So that is what. Fine. So if you go down again, getting the current seed. Yeah. So let's try to understand this one. This is getting the current seed means getting the previous values the random function has already generated. Okay, if you go down, you can see summation of that is the total, how it can be calculated. Okay, purpose of torch random. Now we know what is that. The default range I mentioned, the range is default range is between 0 to 1. Technical basis, so it depends on this PRNG pseudo random number. That's a mathematical function. So based on that only it generates the value random values. Customizing range, I mean, if you want now, for example, customizing range, if you need different for minimum and maximum. Now minimum and maximum means I told you always it is going from more than 0 less than 1. That's the range. No? Random function, you can see the values here. It goes from higher than 0 and less than 1. Not going to go beyond 1. If you want to define value more than 1, you have to do something called scaling. So scaling is not a big thing, and you can see torch random and between pi and 10, and you can see scale. You have to give a multiplication. Now values are between 0 to 10, something like that. So don't need to worry about these things that much, and we can discuss these things as the upcoming requirements are coming in our AI model development. But one thing to highlight here, we can define the range to go beyond 1, not between 0 to 1, by using scaling technique. So just get familiar with this. There is something like this, and you can see again torch random. And earlier we just mentioned within bracket only pi, so it will generate only pi numbers. But now here we can see pi comma 10, and comma 20 into 10. And you can see again that particle also done. It's going to create a two-dimensional array. That is what it's going to do. We can plot it and see. That's what pi comma, actually this is a three-dimensional array, not a two-dimensional array. So random function is going to create a three-dimensional array here. And we can omit this 20 and visualize a two-dimensional array, because getting to know three-dimensional array at this level is a little bit critical. So let's try to understand that one later with NumPy function. With NumPy create arrays, we can understand that one. But the time being, we can see how this one visually, because rather than going through this output in a textual way, we can plot it. We can plot it and see how visually it works. Let's try to do it. I think import torch is already been done. Let's try to, I'm going to import another module called this plot library, and a function called pyplot as plot. Okay, that's a alias. So let's try to import that one here. Let's try to copy this one. Plot. This can be interesting to see graphical plotting. So let's try to define a two-dimensional array, pi rows and 10 columns. Pi rows and 10 columns. Plus 10. This is actually a color mapping. We can see plot show tensor is the assigned variable. It's a tensor actually, torch of random, that's the value. And we want to show it with this color mapping. This is the default. This is the default, and we can see this one. And so it's getting the memory location of the image which is getting created, and that we can show it once the image is being created. We can simply say plot show, and this should display the plotting visually, right? So this is what, very simple. And so you can see now this is a two-dimensional array which is a matrix. You can have 1, 2, 3, 4, 5 rows, and you can see 1, 2, 3, 4, 5, 6, 7, 8, 10 columns. So which is what we asked him to do actually. Pi rows are random values with an array, pi rows and 10 columns. So this is a graphical representation using the plotting. Okay, I think you will learn something on graphical plotting as well, how to use the matplot library module, matplotlib module, and another function pyplot. We have to be careful because main library stores, these are modules we are calling, and here the function import NumPy. Yeah, the explanation is given here at the bottom. What is NumPy and doing? This is another module we have called here. NumPy part of the, you can see this part of the NumPy library. NumPy is like a torch. NumPy is a main library, and in that we have called, you can see function here, we know that, right? And import NumPy, and then a module and the function, and we have seen the plot within that as alias, and this another function image show, right? So that's what you can see. That's why explanation is given here. You can see the matplotlib image. This indicates, you can read and see, I just already explained. This indicates the object belongs to matplotlib image class, is specifically designed for representing image within plots, and this is the memory location of that image. Okay, I hope you understood in this small session how short video, how this random function create linear values like the small range pi random values, how it generates, and you saw how it generates arrays, a two-dimensional array, and how to plot it in a graphical way like this. So that's all. Okay, let's stop the video here. In upcoming, let's see how the 3D arrays can be plotted like this. This knowledge is important for you in upcoming our GAN module. Okay, I'll see you in the next video. Thanks.